Thank you very much for the kind introduction. My only regret about doing this is that I'm not with you all in Oxford. I look forward to that opportunity, but of course we know the world has changed. It's also a great pleasure to me as somebody who is very much involved with not only digital preservation of manuscripts, but creation of metadata and online access, to hear about some of the more cutting edge work that many of you are doing, which is a great complement to our, in a sense, more fundamental work of simply making materials available. So we have several speakers this morning. As you've heard, we're going to allow each one to speak for about 20 minutes, and then we'll have a discussion after each, and then we'll have a wrap-up session at the end, so that if you have questions that cut across the papers, that would be a good opportunity at the end, perhaps, to bring those forth. So without further ado, I think we can get going then. And I'm very pleased to introduce a colleague and friend, Professor Daniel Stoekl Ben Ezra, who is Professor of Hebrew and Aramaic Language, Literature, Epigraphy, and Paleography at the École Pratique des Hautes Études in Paris. His research focuses on early rabbinic literature, Dead Sea Scrolls, computational and digital humanities. I'm particularly interested in his work on the origins of Christianity in relationship to Jewish sources, especially the scrolls. And he'll be speaking to us today on the topic of Beyond Neural Networks, eScriptorium as an edition environment. And I think in the course of that, he'll be able to share some of his very interesting DH work. Daniel.
Thank you so much, Columba, for your introduction, and to Arizu for your invitation, and to Jeanne for the organization of this. It's a pleasure to be here, virtually at least, and it's obviously very sad not to meet around a real table. So what I'm going to present is extremely collaborative work, and I'm the only face here, but there are many other people involved, some more, some less, and in different stages. But I will go right into the middle of matters, which is Patrick Zale's famous text wheel, which is the big advantage of electronic editions compared to print editions. Electronic editions, if properly organized, allow us to approach text from different perspectives, whether it's visual sign as a paleographer, or if you're interested in as a linguist from the linguistic side, or if you're more a historian, you can write your commentary on, or if you're interested in textual criticism, you can have all the different versions of the text. And the last one is the one I'm going to focus on today. It is based around a TEI publisher, which may be known to a couple of you, an open source tool built by Exist, a company that permits you to create your own app to publish your TEI texts as electronic edition, which we did together with Chaim Lapin, my dear colleague from the University of Maryland. So one of the contexts of today is a large project, I would say, to prepare open source TEI XML transcriptions of the major manuscripts of the main extant compositions of Tannaitic, meaning the earliest rabbinic literature. It's about 6,000 pages of a dozen and a half manuscripts from the medieval age. And make these texts available via digital text service, the continuation or the new version of what is known as the canonical text service, and create an edition app. And I'll present some work as progress, which is around the infrastructure we have created in Paris, which is called eScriptorium, which is an AI infrastructure that allows you to automatically train the computer to recognize different zones on the images of objects. It doesn't need to be manuscripts that are of interest for you. So here, for example, we trained the computer to distinguish between text columns and illustrations, or here between different main and marginal lines. Or here we worked on a modern scientific edition and trained the computer to distinguish between two different apparatus. It is also possible to do the same on manuscripts that can be quite complex. Here you see an Arabic manuscript, which shows the ergonomic way you can interact with text that is not written in the writing in the horizontal writing direction, which is a problem we very often encounter when we are working on manuscripts. And we all try to move around our computers, and it's very hard, but here it's the computer that zooms into the zone that is of interest to you, and then rotates the text automatically, and your transcription, either automatically created or manually created, is very conveniently placed below the letters of the manuscript. And what I just showed before are here a couple of images from books or manuscripts that show some segmentation and transcription results. So the third context is a project we have begun half a year ago with Marina Rustova, who's also here, on the large Geniza, on some documents here. And what you see here is an automatic segmentation and transcription of a Geniza document. And there also, there are the automatic features of eScriptorium, but there's also the ergonomic part. So here you have a manuscript with rather complex layout. And if you click on the lines, you can go through them one by one. And it's very conveniently, we are used to it when the lines are horizontal. But as soon as the lines get here to the corner, they are again rotated, and you can continue working as you were with all horizontal lines before. So this is the ergonomic aspect of a platform. So so in order to work on it, you first have to define a segmentation ontology, meaning you have to define what kind of regions and lines you would like to distinguish if you want to work on text. And then obviously, you have also to define your transcription convention. So we use, for example, Leiden Plus. So what you see here, for example, is a manuscript page where we distinguish different types of regions. So you see the main region and the marginal region, and the computer can learn to distinguish them automatically. So they are here in different colors. They are polygonic. They are not restricted to rectangles, and you can perhaps discern slightly, maybe if we approach a little closer, you have these horizontal bars at the beginning of lines, which indicate different line types. So you have the main lines and you have the interlinear lines, and you have two different interlinear lines here, those that are just glosses, and those in yellow here, and in red, those that are text that are corrections that we want to integrate into the main text. And the computer can learn as long as there are geometrical, meaning the location of the page, or graphical parameters that distinguish these types. So he will be able to learn the distinction between the main region and the marginal region, and between the main lines in this type of ink and writing and the interlinear lines, but not between these two types, which were written by the same hand and are looking completely similar. So that's the distinction between yellow and red is manually done. Then you manually annotate segmentation of some pages. You use this as data to train in a segmentation model, that is called, and apply it to other pages, and then you have to correct those until your segmentation is correct. And then you do the same thing with transcription. So you train the computer to learn that. Either for Hebrew, we already have a general model that has been published, and the training data for it also, which you can access online. So you can just run the model on a manuscript, and if you have an existing transcription from other part of the text you need, you can align it and use that as a training ground. Or you can copy and paste page-wise an existing transcription, or you have to manually transcribe some pages. You have obviously to adapt them to your own conventions, and then you can try a transcription model that is specific to this manuscript. And then at the end, depending on whether you want a completely correct transcription, you either correct it, or you think the model is fine and you just want to work with the kind of Google Books quality of text. So for these kind of long manuscripts, you can easily arrive at 97 or 98% of accuracy if the images are good enough. Now, the advantages of eScriptorium for preparing a digital edition is, on the one hand, on the automatic side, it's probably the only fully open source tool. So not only the interface is open source, but also the AI behind the hub is open source, and people can decide to publish their models that they have trained, as we have done, or their training data. That makes it fully controllable by you. There's nothing that is hidden and will vanish. And then there are the interface is quite ergonomic, as you have seen, in order to first of all define regions lines, or to have the page or the lines rotated in the way you would like to. And then what really makes the huge advantage of this is the direct link between text and image on the region and the line level in a huge amount of material. So we are currently transcribing all biblical manuscripts of the Bibliothèque Nationale de France and the Vatican. So it's hundreds of manuscripts with tens of thousands of pages. And this is possible if you have a big enough infrastructure of a computation cluster that can vary that calculation load. You can even go to the text image link on a word level if you realign your text once it has been corrected. There are different possibilities to link several different transcriptions to one segmentation. So I'll soon show the advantage of that. And I hope that it would already be able to show that today. There is going to be probably in the middle of the next month annotation for text and image, for image similar to what Peter Stokes has been done in the Digipal project, and for text as you are used to in TI with tags, for example, for prosoponyms or for abbreviations, and etc. But this database has also obviously its limitations. First of all, data is stored on the line level in the document layout format. And secondly, there is no inherent link between different witnesses. So in order to create a digital critical edition, you need some additional features. So for example, in our project, so we have these 4 manuscripts here for a specific text, and in this case, Siegfried Varin. And we have fully transcribed them. And now we want to arrive here at a text on the right page for those who read Hebrew, but even those who can't read Hebrew can understand that here is some form of main text, and here you have a critical apparatus with the variant readings. We can export from eScriptorium like you can from, for example, from Transkribus in Alto XML or in Page XML, which is following the page layout, and that means it is not following the reading order. Yes, so if you have like here interlinear insertions like up here, or the marginal insertion here, and if you display the reading order as is in the system, so you first have line 1, then line 2, and then line 3, you can see it on the right side. The reading order is completely different of what you would be used to. The marginal addition here comes after the last line of the main text, so 36, 37, 38. That obviously that makes a reading of the text completely impossible. What we do in our projects, so eScriptorium was not constructed as an edition platform. It's constructed as a platform that allows you to automatically interact with the texts. But I think one can abuse the platform, so to speak, if one knows some tricks. So for example, for marginal annotations, we use insertion markers, like this arrow here on the right side. And for interlinear ones, we use another type of arrow. And the computer can then recalculate the distance between the place of these markers in the line and automatically decide which of the different insertions or additions on the margins on the in between the lines is the most susceptible to be linked here. So we can go from this here, in addition, to a canonical text order. So we can align this text, I'll show in a second, and mark the canonical text division with these little editorial marks, like the paragraph and it followed by a number, and do this in all the manuscripts. And then the computer knows where a specific section begins. I already explained the linkage between the interlinear editions and the marginal editions. And the yellows are those that we do not want to insert because they are just glosses that would disturb the reading flow. So this type then we can export through a quite powerful and versatile API in a different type of XML hierarchy that uses the document layout, the page breaks, the column breaks, and the line breaks, the line beginnings that are the decisive tags in the Alto or page XML. Here we can insert them as milestones and use the canonical division of the text into book, chapter, verse, etc. as the main hierarchy of the text, and therefore reconstruct the reading order. And then one can do this automatically. We have an external tool that allows you, once you have a raw transcription of a text, to align it with some other document, either another manuscript or a scientific edition or a Vulgate text or some early modern print. And you can import from there certain features. Like here, we have aligned this text with the early modern edition, or 1931, where we can import the line breaks, the page breaks into the text, and then have the kind of pagination of the scientific edition in the manuscript and use that for the hierarchy. And this allows us then to create the text in reading order. So if we look here, the lines of the manuscript in the infrastructure have been created like this. And then the different interlinear editions have been inserted in parentheses behind at the right spot. And the same is for the 3 lines of the marginal edition. And the one line that we didn't want up here, line number 25 on the top, we could exclude because it doesn't have the correct line type. So the segmentation ontology was very helpful. Then once one has exported all the manuscripts one is working on, one can use their different alignment tools. Collate-X is very famous. For Hebrew, there is a tool developed by Dicta, and we found that the results were best with an algorithm we wrote ourselves based on the classical Needleman-Wunsch. You end up with a table like this that obviously you have to still correct because machines make mistakes. And you can either do it in Excel or use a very nice app the team of my colleague Chaim Lapin has constructed at the University of Maryland with this JavaScript tool, where you can move around the words between the different columns. And then here you can see a mock print. So this is very much work in progress, a mock print apparatus that one can automatically construct on the fly for any manuscript. With the main text in the top and the different readings of the other manuscripts in the bottom. Don't look too closely because there's still many mistakes in here because it's work in progress. Our aim, obviously, is not to get to only a print edition, but to get to this into our TEI publisher platform, which is what we are currently working on. And what we would then like to be able, for example, is that if you hover with your mouse over the words in the apparatus, that you would actually see the words cut out from the other manuscripts, and you could directly compare it without having to go to the other manuscripts. What we can already do through the alignment is export all words of a certain type. We can also go to the glyph level, but it's less precise due to the LSTM networks behind it. So instead of a conversion of the database structure, as you see here, to a document layout formatted around page, blocks, lines, and strings, ours goes to the canonical versification using as tricks, one could say, the editorial markup in the transcription. The alignment, the textual alignment, can help for lots of other things to speed them up. For example, we can align, as I showed before, not only in order to get the pagination, but also in order to get the biblical references. So if you worked on Quran, you could get the Quranic references if they are in some printed edition of your work. Or you can resolve abbreviations. Like we indicate here with apostrophe, and you see here below that in the interface, the edition that has spelled them out fully. Or you can compare differences in the text and spot some mistakes that are still there. As I said, all the code of eScriptorium is openly available. We have a blog, which you see here, the UI code and the I code, and graciously indicate our funders. And for the specific project on the rabbinic manuscripts, I'm very happy to thank a foundation that prefers to rename unnamed. There's one last point to mention, that is a Mirador text overlay plugin that was constructed by Johannes Jbaiter at the university, at the Library of Munich, where you can simply add an alto into the manifest, and then you can create the text overlay of your transcription and the manuscript. So for those of you who are working on manuscripts with manifest, this is really probably very useful. Thank you very much.